Hello everyone, today we are going to start lecture 04 of class 8 mathematics chapter number 10, which is visualizing solid shapes. Now in this lecture we are going to talk about an important formula which is known as Euler's formula. Throughout the lectures we have seen that there is a certain linear relationship between number of vertices, number of faces and number of edges of a convex polyhedron. Let us define what that certain relationship is and what it actually says, and with the help of this formula how can we actually calculate the number of vertices, number of faces and number of edges of a convex polyhedron. So let us define it. Euler's formula says that the number of faces, edges and vertices of a simple convex polyhedron are connected by the formula V plus F minus E is equals to 2, or you can write it V plus F is equals to E plus 2, which is known as Euler's formula. Right, so you can clearly see that this formula is the formula which connects the number of vertices, faces and edges of a convex polyhedron. Now what does this V, F and E stands for? So we can write here V stands for number of vertices of that convex polyhedron, F stands for number of faces and E stands for number of edges of that convex polyhedron. So here it is pretty clear from the formula that vertices, faces and edges are connected, and the sum of vertices and faces is actually equals to 2 plus the number of edges, right? So vertices and faces basically are always smaller than the number of edges, but their sum is 2 more than the number of edges. Now this formula is basically used for calculating the edges, faces and vertices for pyramids and prisms, because they are what basically we study, right? So let us have some questions that how this Euler formula can be used and how questions can be asked on this particular concept. So let us see the first question. A polyhedron has 30 edges, which is basically E, 20 vertices, that is V. How many faces does the polyhedron have? So it is a very simple question on direct formula. So let us first write what is given here, comma, for a polyhedron, comma, number of edges, that is E, is equals to 30, number of vertices, that is V, is equals to 20, and number of faces, that is F, is equals to question mark. Now it is asking to find this number of faces. Okay, so we can write from Euler's formula, what we have V plus F is equals to E plus 2. So if we apply the values in here, we will get V is equals to 20, number of faces we have to found, and E would be 30 and then plus 2. So we can have equation as F is equals to, this will be 32, 32 minus 20. Okay, we have transposed 20 from LHS to RHS. So F would be 32 minus 20, which is equals to 12. So the polyhedron or the given polyhedron, so the given polyhedron will have 12 faces. Okay, now it might be prism, it might be pyramid also. Okay, but the one thing you should note in this question is that the number of edges is 30 while the number of vertices is 20 and number of faces are only 12. So you can clearly see there is a huge difference between number of edges and number of faces, right? Because basically for even a smallest polygon, 3 edges are required to make a face. Also these edges are shared by some other faces also, but you should always remember, I'm telling you this because sometimes in MCQs what happens, because of your wrong calculation, you might get number of faces or vertices greater than the number of edges. If you see that, directly cross out your question. It is wrong. It is absolutely wrong, because you can see that even for, you can experiment it on a number of figures, but number of edges would always be more than number of vertices or number of faces. And that is why even in the Euler's formula, number of vertices and number of faces have to be added just to get 2 more than the number of edges. So you can clearly see. Okay, this concept will basically help you in solving out the MCQs. Let us move on to the next question. Now this question says that can a polyhedron have 10 faces, 12 edges and 15 vertices? Okay, so how will you check it? That is, it is basically asking that is it possible to make a polyhedron with these specifications? Now see, we do not even know that what kind of polyhedron is the question talking about. Is it talking about some kind of prism, or is it talking about some kind of pyramid? So how will we actually identify it? Simple, we just apply the Euler's formula. If it is a simple convex polyhedron, it will satisfy the Euler formula, and if it does not satisfy, then we can understand that the polyhedron cannot be possible with such specifications. Okay, clearly the first test which we should do is see that the number of edges is greater than faces and vertices. So you can move on and apply the Euler's formula. Okay. It is given, that number of faces, which is basically F, number of faces, this is basically F, is equals to 10. Number of edges, which is basically E, is equals to 20, and number of vertices, that is V, is basically 15, right? So number of faces 10, number of edges 20, and number of vertices 15. So you can clearly see that it is given for a polyhedron. Basically it is given for a 3D figure, and it is asking is it a polyhedron. So let us check. Now by Euler's formula, we have V plus F is equals to E plus 2. Now let us check if it happens or not. That is 15 plus 10 is equals to 20 plus 2, implies that 25, 15 are the vertices, 10 are the faces, 22. 15 is equals to 22, which is, you can clearly see, false. You can write which is false. That is, the given F, E and V do not satisfy, that is the given values of F, E and E do not satisfy the Euler's formula, right? The given F, E and V do not satisfy the Euler's formula, right? So a polyhedron cannot have, because directly you can say that the polyhedron cannot be possible with such given specifications. So a polyhedron cannot have 10 faces, 20 edges and 15 vertices, right? So it is pretty clear that this Euler's formula is not only helping in finding these things, even it is helping that in finding that whether a polyhedron is possible or not, right? Let us move on to the next question. Now this question asks that is it possible to have a polyhedron with any given number of faces? Now see, it is a very vague question. You can say, see sir, no, with one face no polyhedron is possible. Even one face is not even a 3D figure, it is a 2D polygon. Similarly with two faces also it is not possible. Even for three faces you cannot make a 3D closed polyhedron, right? So you will at least need 4 faces. So the question arises that okay, minimum polyhedron or smallest polyhedron should have 4 faces, which is a tetragon basically. But after that, is it possible to have any number of faces? Yes, it is true. So we can write the solution as, the solution is positive, that yes, okay, we can say a polyhedron is possible, but it should have at least 4 or more faces. Yes, it is possible. Yes, it is possible to have a polyhedron with any given number of faces, but they should be 4 or more, right? You can say that sir, yes, it is possible that you can make a polyhedron with any number of faces. You can have a polyhedron with 10 faces, 11 faces, 9 faces, but the faces should be greater than 4. And you should always add one more line over here, that which says minimum number of faces required, minimum number of faces required to make, minimum number of faces required to make a polyhedron, minimum number of faces required to make a polyhedron is 4. Okay, and what is the name of polyhedron with 4 faces? It is called tetrahedron, right? You can also call it triangular pyramid, which is the basically tetrahedron. Okay, that is, you will make tetrahedron, that is the smallest polyhedron possible with minimum number of faces, right? So this was the answer. Let us move on to the next question. Now this question says that what is the least number of planes that can enclose a solid? What is the name of that solid? Now again, it is again the similar question in just different words. So it is asking that what is the least number of planes? What are planes? These are faces only. Okay, so that can enclose a solid. So least number of planes required to make a solid is 4. We have just answered it. Okay, and what is the name of the solid? Tetrahedron. So we can write at least 4 planes, at least 4 planes are required, at least 4 planes are required to make a solid. Okay, name of the solid is tetrahedron, or you can say, or triangular pyramid. Right. So see, with the help of Euler's formula, you can do a lot. You can find that how many polyhedron can be possible, or is it a polyhedron or not, with the if you are given the number of vertices and all these things, right? So you should remember one more thing here, that even in a triangular pyramid, the number of faces are triangular. The number of faces are 4. All the faces are triangular, right? Now, if you want to make a polyhedron with 5 faces, then you can clearly see that you can even go for a prism. A triangular prism has 5 faces. Similarly, you can go for square pyramid. So you should remember that it is not necessary that on a particular number of faces there is only prism available or pyramid. There can be both, right? If the requirement is that you have to make a solid with just 5 faces, I'm telling you, in multiple select questions and even also MCQs, they ask that is only prism possible or pyramid possible if we have to make a polyhedron of 5 faces. Both are possible. Even if you go for square pyramid, it also has 5 faces, because it is not mentioning that which kind of faces. It only says that 5 faces and you should have a polyhedron. So you can have a square pyramid. It also has 5 faces. You can also have triangular prism. Triangular prism also have 5 faces. 2 triangular, 3 rectangular, right? So you can clearly see that different kind of questions can be made on the simple concept of Euler's formula, right? Let us move on to the next question. Now this question says, can a polyhedron have for its faces 3 triangles, 4 triangles, and a square and a rectangle, right? A square and 4 triangles, right? So 3 triangles, 4 triangles, a square and 4 triangles. So can a polyhedron have these? See, if you see the first part, you can clearly say that no sir, 3 triangles cannot make a polyhedron, because we have just answered that at least 4 sides, at least 4 planes are required to make a simple smallest polyhedron, which is the tetragon. Okay, so you can write here for the first part, minimum number of faces required to make a polyhedron is equals to 4. Okay, so minimum number of faces required to make a polyhedron equals to 4. So 3 triangles cannot make a polyhedron, right? So 3 triangles cannot make a polyhedron. That is basically the answer. Let us move on to the second part. The second part says that can a polyhedron have 4 triangles? Obviously, we have just answered triangular prism has 4 triangles. Okay, and the name of the figure is also tetrahedron, which is triangular pyramid. Yes. So the second part is yes, a polyhedron can have 4 triangles, for its faces. Yes, a polyhedron can have 4 triangles for its faces. That polyhedron is called triangular pyramid, right? So yes, a polyhedron can have 4 triangles for its faces. That polyhedron is called triangular pyramid. Let us move on to the third part. The third part says that can a polyhedron have a square and 4 triangles as its faces? So we can write yes, a polyhedron, because see, 4 triangles and square means 5 faces. Okay, but it is not talking about the number of faces. It knows that yes, 5 faces, but it says that is it possible that with one square it can be 4 triangles? Yes, it is possible. And seeing triangles as the faces, you should always click or you should always go towards pyramid, right? Yes, a polyhedron can have a square and 4 triangles as its faces. Now, which kind of polyhedron? Square pyramid. If you see, square pyramid has base as a square and all the 4 other lateral faces would be triangles. Yes, it is called square pyramid, right? So yes, a polyhedron can have a square and 4 triangles as its faces. It is called square pyramid. So it is very simple. Let us move on to the next question. Now this question says that using Euler's formula, find the unknown. Again, it is a very simple question, direct application of the formula. So we can easily solve it. If you take them as parts, you can clearly see in the first row, if I go it for first, second and third, then you can see in the first part, f is equals to unknown, v is equals to 6 and e is equals to 12. So v plus f is equals to e plus 2 implies that 6 plus 12 is equals to, f we have to find. So 6 plus f is equals to 12 plus 2. 12 plus 2 would be 14. So f is equals to 14 minus 6, which is equals to 8. Right. So you can write 8 over here, or you can write 8. Right. So this was the first part. Second, if we have to go to the second part, then in second part we have f is equals to 5, we have v is equals to unknown, and we have e is equals to 9. So for this polyhedron there are 5 faces, 9 edges, but vertices are unknown. So if we have to find the vertices, then we can clearly see that v plus f is equals to e plus 2, which implies that v, because it is unknown, f is equals to 5 is equals to e, that is 9 plus 2, which will give us v plus 5 is equals to 9 plus 2, that is 11. Okay, and then v is equals to 11 minus 5, which is equals to 6. So that would be 6 and f would be 8. Okay, so number of faces would be 8, number of vertices would be 6. So we can fill out 6 over here. Right. Let us take the last part. It says number of faces is equals to 20, number of vertices is equals to 12, and number of edges is equals to unknown. Okay, so we can, with the formula, v plus f is equals to e plus 2, we have 12 plus 20 is equals to e plus 2. So e plus 2 is equals to 32, which implies that e is equals to 30. Right. So there would be total 30 edges. So you can clearly see that this was all about Euler's formula, and Euler's formula is a very simple concept. You just have to remember that the number of vertices, number of faces, their sum would be equals to e plus 2. So you have to remember the formula. Also, if a geometrical figure, if a polyhedron is given, then you should be able to count the number of vertices and faces. Sometimes it also happens that they can give you a figure and then say that verify the Euler's formula. So you should be able to count what are the number of vertices, number of edges, number of faces, and you should be able to do that only when you have revised these figures, and you just recognize the figure that yes, it is a square pyramid, it is a regular octahedron, it is a hexagonal pyramid, and all those things, right? So this was all about this particular lecture. Thank you for watching this lecture till end. We'll meet in the next lecture. Till then, goodbye.